Sodium acetate is often used in common household products such as heating pads and hand warmers. The crystallization of supersaturated sodium acetate, forming hot ice, is an exothermic reaction and thus it warms the heat pads and hand warmers. This concept works on the principle of chemical energetics and enthalpy change. An aqueous solution of sodium acetate is first prepared in hot water, with temperatures at about 100 degrees Celsius. The solution is heated to drive off water molecules and to allow the solution to become saturated. After which, the solution is cooled to a temperature lower than room temperature. As the temperature of the sodium acetate solution approaches 0 degrees, solubility of the sodium acetate in water decreases, such that the concentration of the cooled sodium acetate solution is much higher than the saturation point at that particular temperature. Hence, the sodium acetate solution becomes supersaturated. In order for crystallization to occur, a defect or rough surface, such as an impurity or a scratch in the material containing the solution, is needed. The metal discs in the heat pads have ridges and specially roughened surface. When it is clicked, the disc is bent. The bending of the metal disc results in some very tiny particles of metal being released from the roughened surface. The tiny particles of metal act as a nucleation point to initiate crystallization of the sodium acetate. The point of the beginning of crystal formation is also known as the nucleation point. A nucleation point is a localized formation of a distinct thermodynamic phase. There are two types of nucleation, homogeneous and heterogeneous nucleation. In this case, we are looking at heterogeneous nucleation as it involves nucleation sites on the surface contacting the liquid. Homogeneous nucleation only takes place in the interior of a uniform substance and is much less common than heterogeneous nucleation. In heat pads and hand warmers, the metal particles are the nucleation sites. As the solid sodium acetate crystals form from the aqueous solution, there is a decrease in the entropy of the system. This bond-forming process is exothermic, and hence the heat pads and hand warmers are able to work as heat energy is emitted during the process. The materials needed for making hot ice are baking soda, vinegar, and water. First, add 1 tablespoon of baking soda or sodium bicarbonate into a large pot. Then, measure out 300 ml of vinegar. Then, add the vinegar to the baking soda and stir until a clear solution is obtained. Then, heat the solution for about 20 minutes until most of the water in the vinegar is evaporated. You were able to see sodium acetate solid deposits at the sides of the pot. These are your seed crystals. Afterwards, place it into a bath of cold water to allow it to cool. In order to achieve supersaturation, place it into a smaller container so that we can put it into the fridge to allow it to achieve a lower temperature. Apart from sodium acetate in heating pads and hand warmers, other applications of supersaturation include carbonated water, which is created by preparing a supersaturated solution of carbon dioxide and water. A supersaturation solution of sugar and water can also be used to make rock candies. Nucleation can also be observed when bubbles form on the surface of a straw immersed in a soft drink and the creation of liquid droplets from saturated vapor.